I'm Willie Davidson. I'm at Simon Fraser University, and I'm here representing the salmon genome projects that have been funded by Genome Canada over the past 10 years. So with Ben Coop and with people in Norway, Stig Omholt and others, we've been developing genomic resources for salmonids using Atlantic salmon as the reference, and these resources are then being applied in areas such as aquaculture, sustainable aquaculture, the management of wild fisheries, and also being used to monitor the environment. So Environment Canada is using these resources, aquaculture industry and fisheries and oceans are using these resources. Specifically, we've been asking how many different genes are there in Atlantic salmon, and by extension to other salmonids. How are these genes expressed when the salmon are under stress with climate change, with changes in temperature, changes being affected by pathogens, for example, or being exposed to industrial pollutants from pulp mills or from human waste. Then we've been working to get genetic markers, and a lot of these genetic markers can then be used in breeding programs. So we've been doing that in Atlantic salmon, and our end user, one of them is Icy Waters, who produce Arctic char in the Yukon in Whitehorse. And I've got with me today Colin McGowan, who's been the broodstock development manager for Icy Waters, and over the past 5 years has been using the salmon resources to build a better Arctic char.
Well, some of the benefits for Icy Waters have been to be able to use some of the genetic markers and a lot of the technologies that have come out of this project and applied it to our own breeding program. We've been able to use these markers for marker-assisted selection of traits such as growth and disease resistance. And one of the things we're interested in for the future is looking at upper temperature tolerance of Arctic char to see if we can grow them at more southerly climates where the water temperatures might be a little bit warmer and restrictive for this particular species. Well, certainly as water temperatures warm up, I think some of the interesting thing that's come out of this project is looking at the expression of genes when fish are exposed to water temperatures, and can you use these sort of expression patterns to detect whether or not a fish might be under stress in the natural environment, and whether warming water temperatures over the long term are having an effect on the wild populations.
Just kind of